Precipitation. Precipitation and soil. Soil and water being splashed by the impact of a single raindrop. Rainfall and the surface runoff, which may result from rainfall, produces four main types of soil erosion: splash erosion, sheet erosion, rill erosion, and gully erosion. Splash erosion is generally seen as the first and least severe stage in the soil erosion process, which is followed by sheet erosion, then rill erosion, and finally gully erosion, the most severe type of erosion of four. In splash erosion, the impact of a falling raindrop creates a small crater in the soil, ejecting soil particles. As you may see on this image, a small tip covered in rills and gullies due to erosion process caused by rainfall. This is a type of hill which is located in Rumu, Estonia. The distance these soil particles travel can be as much as 0.6 meters vertically and 0.5 meters horizontally on a level ground. If the soil is saturated, or if the rainfall rate is greater than the rate at which water can infiltrate into the soil, surface runoff occurs. If the runoff has sufficient flow energy, it will transport loosened soil particles, sediment, down the slope. As you may see here on the image, the surface runoff creates soil erosion, and due to intensive irrigation practices, and soil is so saturated that it cannot infiltrate water, and water due to slope, especially on areas prone with high steep slopes, starts to cause water erosion. Sheet erosion is the transport of loosened soil particles by overland flow. So this is a type of sheet erosion. So mean annual precipitation, British Columbia. So precipitation can be displayed and represented in GIS platforms, because precipitation also varies spatially from region to region. So here on this image you can see the precipitation for southern British Columbia, mean annual precipitation, and in some areas there is a very high level of precipitation, in other areas very low level of precipitation in millimeters. So how this was calculated, spatially represented. So basically hydrologists and meteorologists gather field information from multiple locations for each month, and finally they sum up all months precipitations for a certain year, and thus creating annual precipitation. Precipitation influence on erosion. So how precipitation might cause erosion? So which factors of rainfall and snow also, and other types of precipitation might cause erosion process? So this depends on frequency of precipitation, how often do your study area and experience precipitation and rainfall, and etc. For instance, in some areas almost every week, twice a week. Meanwhile, in other regions, once in 3-4 months, mostly in arid and semi-arid regions. Also, it depends on intensity. So intensity of each rainy day, for instance. In certain days, intensity of rainfall can be very slow, but the duration may be higher. For instance, in some regions, for instance in my region, the precipitation might be with low intensity, but continue 2 days. But in other regions, for instance, especially in certain seasons, in summer for instance, the intensity of precipitation can be tremendously high, but duration is only 1 or 2 hours. So, and the size of the area, so on which areas precipitation raindrops fall. So this type of precipitation data, which gathered by meteorologists and climatologists also. So we can see that precipitation varies from month to month. So this is field data, all valid and verified precipitation data gathered by field experiments. So they show always precipitation always linked to longitude and latitude. This is the area of British Vancouver. Also see that average elevation of study, and this is our monthly precipitation, and these are other types of data which meteorologists also always gather. So this is for year 2010. So but there is also a modeled precipitation which was created by University of East Anglia Climate Research Unit. So we can see on this image this is a global data for global precipitation in net CDF format, which you can find through this link, and we will download also this global precipitation data and afterwards extract for our study area. But this is just estimation of global precipitation. If you have your own precipitation data, it is always more accurate, and it is better to use for your analysis.